You know how AI-generated reports can sometimes feel, I don't know, a little too perfect, a bit stiff? Well, what if the secret to making AI a better researcher is to actually make it a little more messy? Yeah, a little more human. A new paper from Google is exploring exactly that. And we're going to unpack this groundbreaking new framework.
I mean, no way, right? If you're anything like me, your process was this total chaotic dance. You write a bit, you get a new idea, you go down a rabbit hole searching for something, you come back, you revise everything, maybe you just delete a whole page. It's iterative, it's messy, but honestly, that's how the best work actually gets done.
And this, right here, shows you the fundamental problem. Our human process? It's a loop. We plan, we draft, and then we get stuck in this cycle of searching and revising, over and over, making it better each time. But most AIs? Nope, it's a straight line. Plan, search once, write, and that's it. It's done. There's no loop, no feedback, no aha moments that send it back to the drawing board.
And that rigidity, that one-way street is a massive wall. It's the reason why so many AI agents just can't handle really complex, long-form research. They just don't have a built-in way to do what we do naturally. Draft something, look at new info, and then go back and fix their own work.
So to knock down that wall, researchers looked right at us for inspiration. They came up with this new framework. It's called the Test Time Diffusion Deep Researcher, or thankfully, TTD-DR for short. Now, that word diffusion is super important. We'll get to what that means in a sec, but the big idea here is to build an AI that actually thinks and writes in those same messy iterative loops that we do.
Okay, so this is the central concept, and it's pretty cool. They're treating the writing process like what's called a diffusion process. The best way to think about it is like this. Imagine you have a really blurry, noisy photo. The AI starts with a rough, noisy first draft. Then, with each step, it denoises that draft. It uses new information to make it a little sharper, a little clearer, until you end up with a crystal clear, high-quality final report. It's literally refining chaos into clarity.
So how does this actually work in practice? Well, it's a really elegant four-step loop. First, the AI just churns out an initial, kind of messy draft. Step 2, and this is the genius part, it uses that draft to figure out what it's missing, what it doesn't know, and then it goes searching for answers. Third, it takes all that new information and weaves it back into the draft, denoising it. And finally, it just repeats that whole thing. The now smarter draft leads to an even smarter search, which leads to an even better draft. It's this awesome self-improvement cycle.
All right, so let's pop the hood and see how the magic actually happens. So TTD-DR's success really boils down to two powerful algorithms that are working in perfect sync. It's not just one thing, it's how they play off each other that's so effective.
So mechanism number 1 is what they call denoising with retrieval. This is that awesome feedback loop we were talking about. The draft itself is basically in the driver's seat. It's smart enough to see its own weaknesses, its own gaps in knowledge. Then it sends the agent out to, say, Google search to find those missing pieces, and then it weaves them back in. It's like the report is a living document, constantly evolving and getting smarter with every single cycle.
Okay, the second mechanism is called component-wise self-evolution, which sounds complicated, but the idea is simple. Think of the AI as a research team. With this mechanism, every single member of that team gets better at their job during the project. The planner gets better at making outlines. The question generator gets way better at asking insightful questions. The part that synthesizes answers gets clearer. So with every loop, the building blocks for the final report are just higher and higher quality.
Okay, so the theory is fantastic, right? But does it actually hold up in the real world? Let's get to the proof. The researchers put TTD-DR in the ring against some of the heavyweights in AI research, and, well, let's just look at the numbers.
And, wow, the results are pretty staggering. When they put it head-to-head against OpenAI's deep research product, TTD-DR came out on top over 69% of the time for long-form research. And check this out. For the really tricky business and consulting stuff, that win rate shot up to almost 75%. I mean, it didn't just squeak by. It completely dominated the competition.
Just looking at this, you can see it's not even a fair fight. We're not talking about a small, incremental improvement here. This is a huge leap forward.
Let's just pause on that number for a second. 74.5%. That means in the world of complex, high-stakes business queries, people preferred its output almost 3/4 of the time. That is an absolute game changer.
So the researchers also dug into why it's so good. They did these tests where they took parts away to see what happened. And what they found was that, yeah, each of those two mechanisms helps a bit on its own, but the real magic, the massive leap in performance, happens when you put them together. That draft-focused denoising process, combined with the self-improving parts, that's the secret sauce. They're way more powerful together than they are apart.
Okay, so let's zoom out. What does this all mean for the future of research? Why should we care about this beyond just some cool tech?
Because really, this is the big takeaway. This is so much more than just a technical upgrade or a better algorithm. It's a fundamental shift in how we think about building AI. We're moving away from these rigid assembly line AIs and towards something that can actually think, explore, and create in a way that feels, well, a lot more human.
So, to wrap it all up, the key thing here is that by mimicking our own messy, iterative process, this thing gets way better results. That whole draft-centric approach keeps it focused and on track. It's genuinely state-of-the-art, outperforming the big guys. And maybe the most exciting part? It really points to a future where AI stops being just a tool we use and starts becoming a true research companion.
And that really makes you think, right? As these systems get better at thinking and working like we do, that line between tool and collaborator starts to get really blurry. It leaves us with this one big, fascinating question to ponder. Will your next research partner be an AI?